Okay, so 12A, a lot of you, well, some of you got it finished in class and a lot of you are very close to finishing, so hopefully we're all ready to go with 12B, and some people have even finished that. Okay, so 12B is all about, it says tree diagrams, but it also has some tables in here as well. So it says you can often use the approach of graphing simple probability scenarios. You can use tree diagrams. Anyway, example 1. A fair 6-sided dice is rolled twice. List the sample space using a table. When it tells you that there's a roll 1 and a roll 2, it is important the order that you put them in when you list your sample space. Okay, so roll 1, the number must go first. So 1 and then 1 for that first one. 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. So the number in the column is always going to be the first number. So quickly go through and fill that in. Oops. Okay. Sometimes the questions won't actually ask you to draw up the table, but please feel free to always draw one up for the kinds of questions where you are doing two things, like rolling 2 dice or 2 coins, those kind of things, because it is easier if you have that visual. So let's answer the questions. How many outcomes are there? You're just going 6 times 6 or counting them all up. There is 36 different outcomes for rolling 2 die. Part C, find the probability of rolling a 1 and then a 5. It is indicating there that the order is important. The 1 must be first, which means it is that situation there only. One of them out of the 36. Part D, find the probability of rolling a double. So your doubles go on the diagonal, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And there is 6 of them out of the 36, which simplifies to a 1 out of 6 chance. Find the probability of rolling a sum of 7. You'll notice the more that you look at these table with the 2 dice, that there is patterns when you add them up and they go on a diagonal. So this one here starts in this corner, 1 plus 1 is 2. 1 plus 2 and 2 plus 1, they both add to 3. This diagonal down here adds to give 4. This is your 5 diagonal, 6 and so on. And I'm looking for the diagonal 7, which is here. 7, 7, 7, 7, 7, 7. So that was 1, 2, 3, 4, 5, 6 of them again, out of 36, which we already know is 1 out of 6. Find the probability of rolling a sum of at least 9. So keeping that diagonal in mind, if I find a sum of 9, there's 1, so 6 and 3 makes 9, and I go on the diagonal. 5 and 4, 4 and 5, 3 and 6 makes 9. But it says at least 9, which means it can be bigger than that, which means the 10 diagonal, the 11, and the 12, all of those ones with a little red asterisk and little red star in there, they are all possible outcomes that we want here. So if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 of them out of 36, which simplifies to a 5 out of 18 chance. G, Find the probability that at least one number is a 6. So that would mean I can roll the 6 first, which would be anything in that row, or the 6 second, which would be anything in this column. Don't count 6, 6 twice. Okay, so there is 11 favourable outcomes there. 11 out of 36. Find the probability of a sum that is not odd. Now, not odd, odds and evens are complements of each other, so it means I want all the even numbers, sums. So you can have a look through and we can work on our diagonals here. I'll just draw a line this time. So, circle. That one, so that's even. And fours, the fours are going to be even. Those ones all have a sum of 4. The 6s, which would be that one, that one, that one, that one, and that one, are all even. 8s, 10s, and 12s. But you can see by that pattern, how many is that? It's exactly half of them, which does make sense. So if you count them all up, there is 18 out of 36, which does come out to be exactly half of those outcomes. On the next page, we get to a question where 3 coins are being tossed and we want to draw a tree diagram to show the outcomes. It's good if you include a little heading for each time that you toss the coin. So I'm going to have the first coin, the second coin, and the third coin. Sometimes those things are kind of obvious, but depending on the situation, it's actually really handy to have those headings up there so you know what each thing indicates. So the first coin, I can either get a head or a tail. And some of you may need a little bit of practice trying to set your trees up so they don't look like they're kind of wobbling all over the page, okay? So try and keep your outcome. I've got first here, I've got my head and my tail. I'm trying to keep that all in a line underneath there, okay? So then when I'm coming to the second one, I'm going to extend my branches out so that all my outcomes are underneath that one. So if a head is rolled the first time, I could get a head or a tail the second time. And also if I rolled a tail, I can also get a head or a tail for the second one. Each of them branches out. And then for the third coin, each of them is going to branch out again. Keep them in line underneath that heading. Okay, so that is what we call a tree diagram. And the good thing about a tree diagram is that all of the branches are equally likely. Okay, so we don't actually have to write probabilities on the branches. If you remember the other type of tree that we call a probability tree, where we write numbers on the branches because there might be the ones with the marbles in the bag. You know, might have 3 red ones and only 2 green ones, so they're not equally likely outcomes. But this one, they are all equally likely, so no numbers are needed on the branches, but we do need to list out the outcomes. So along the top row, we have head, head, head. So out the side here, for the outcomes, the first one is H, H, H. And then we need to do that for each branch. The next one will be head, head, tail. Head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So there is 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 outcomes. Now that we have a nicely drawn tree, we want to find some probabilities. So in part B, find the probability of selecting 3 tails. Now because we've listed our outcomes over here, 3 tails is this one right here, TTT. It only can happen one way, so it is a probability of 1 out of the 8 different outcomes that were possible. Right? 2 tails, looking through for 2 tails would be this one this one, or this one. There are 3 different outcomes that involve 2 tails because the position of them is not important, but there is 3 of them out of the 8. And the last one says at least 1 tail. That means it could have 1, 2, or 3 tails in it. The only branch that we don't want is the one that is head, head, head. Okay, because that's the only one that doesn't have at least 1 tail in it. So that means it's going to be 7 out of the 8 that have at least 1 tail. That's it. We will do the harder type of tree diagram in a couple of exercises' time.